what is the HomeGrid Forum? So we actually started, this industry alliance started in 2008. It comprises of system vendors, like for example, Aris, D-Link, those type of system vendors, silicon providers, such as Marvell, Sigma Designs, Metanoia, Xactera, and service providers such as AT&T, CenturyLink, British Telecom. AT&T is actually the chairman of our board. I actually work for Marvell, which is a semiconductor company, so I'm actually on the silicon side of the house. And the first commercially deployed G.hn devices came out in 2013. Now, folks, since not a lot of folks know what G.hn is, so G.hn is actually a standard, and from a silicon standpoint, it is one chipset that can actually be utilized on many different technology platforms. So this same chipset can work on Powerline, can work on coax, can work on POF, which is plastic optical fiber, as well as coax. And traditionally, the way that these technologies have proliferated prior to G.hn, I'm sure if you guys have heard of Mocha and HPNA or HomePlug. Usually you need one chip for one technology. One chip for Mocha, one chip for HomePlug, one chip for... This chip actually works on all different mediums. And it doesn't actually have a degradation of each different technology. Like for example, because it works on coax and Powerline, somehow you get something lesser than from each media. It actually has, from a testing standpoint, higher performance, higher security, better latency, and the whole thing. I'm not going to go down into the weeds just because this is a 20-minute conversation. So I'm actually going to probably focus on one technology. If there's a certain technology that you guys need any Q&A on, just please feel free to interrupt me and raise your hand. So the purposes of this meeting, the technology I'm going to focus on is Powerline, just because from a consumer sense it's more ubiquitous. You see it more in retail, and service providers tend to do both Powerline and coax. What makes a great backbone? One of the things that, from a profession standpoint, that I'm seeing in the carrier space is that people had this idea that wireless was going to be the panacea. They deployed wireless set-top boxes for the last, couple of years, and then they started seeing kind of a non-serviceability issue, where anywhere from 20 to 40%. And it ranged on the different topographies that they were deploying at. The people who deployed more in MDU saw a higher percentage of non-serviceability. People who deployed into single-family homes didn't see it as bad. They're more in the 20% range. And when they say non-serviceability, it's usually issues like, when we tried to do wireless, but we had a brick wall, or we had contention with spectral issues because of the apartment complexes. There was a whole myriad of things where they had to use some type of form of backhaul or wired medium, either straight Ethernet or existing coax in the home, or even some of them are actually even doing Powerline. This is where this technology started kind of getting its legs in terms of being the backbone to help extend either wireless or use existing in-home wiring to proliferate it instead of wireless. So for the purposes of this, what makes a great backbone? For our technology, we think there's three key elements. No interference, security, and of course, the highest performance. So I'm not sure if you guys have seen this in the retail space or retail world, that everybody's now trying to solve the dead spot or the dead zone. Have any of you guys seen that type of marketing that's out there, where you got your wireless, you have your either a trillion spatial streams that are trying to hit every corner of your house, but then it can't hit all the corners of the house. You want it to work in the patio, you want it to work in the garage, you want to work, there's different areas that a consumer wants to have their internet. Some of the folks that have launched our technology in the retail space have launched it in Powerline, and they're using this thing called, the dead zone. So they're integrating this technology into an actual router. So the router itself is already pre-wired with G.hn, and it literally has to get plugged in anyways, because you have to power it. And inside that power cord in that wiring is the technology. So it's already completely lit as you plug it in, through Powerline. And on the other end, they're using just an adapter that's Powerline to Wi-Fi to the concept is a sprinkler system throughout the home. And they utilize this same type of concept is what would happen with the cellular networks, right? There was Macrocells, was the cellular network, and in order to proliferate the coverage area because of all the propagation of cellular networks, they actually did microcells, so they can actually hit. And it's the same exact concept from a cellular side to that they're doing in the in-home networking side. They call it the sprinkler system effect. Or I would say a carrier has called it, one carrier has called it the sprinkler system effect. So one of the biggest questions I get asked all the time is, okay, so how do you compare wired to wireless versus Wi-Fi to Wi-Fi? And there's a lot of extenders out there that does Wi-Fi to Wi-Fi roaming. Isn't that good enough? I mean, is that, is mesh work? And I agree, mesh is actually a great way to also proliferate video and data, but the issue with mesh that we've seen in a lot of the carriers and deployments is latency. You can't get around that. Wi-Fi to Wi-Fi latency is like 20 to 30 milliseconds. From a wired backbone to Wi-Fi, you're actually cutting out that latency and actually extending the Wi-Fi, where now you get the full propagation of that wireless output. Where if you would Wi-Fi to Wi-Fi, you have that kind of client access point, cut in half, and your throughput gets cut, your latency goes down. My background is engineering, so I can tend to go into the weeds if I want to, but I have to get out of the weeds. So from a pure, so what we'd like to also distinguish ourselves as a technology, G.hn, from a power line side, the other power line technology, power line in and of itself is its own worst enemy, right? Power line, I mean, people knew, when you say power line, people are like, oh God, that thing had issues with my treadmill, that the legacy technology of power line had its own issues with working panels, noise, the whole thing. G.hn power line, we like to call it the new power line. We don't have issues working through panels. We work through AFCI outlets. We like noise better. You'll even see it in the retail reviews that just came out in the last year, where they're questioning what made this work better. The further you go out into the homes, the better the throughput it was. I mean, the industry is actually confused on why is this power line all of a sudden a better power line. And it's fundamentally because of the underlying technology. G.hn is different than HomePlug AV. And from a technical side, if you guys want to go to the weeds, we are based on time division multiplexing, almost kind of like Token Ring. So it's not collision based, so it's not like a spray and pray and then good luck on your video. So this is actually time division, and it's actually specific for 4K delivery. One of the carriers, there was an announcement that Bell Canada launched 4K TV, and what they're propagating that 4K TV is two things: Wi-Fi based on Quantenna, and G.hn based on Powerline. So they're actually calling us the Quantenna of Powerline, which is a coinage that they're using from a technology standpoint. So like I was saying, from a three big issue from legacy Powerline, we solved the issue of AFCIs, panels, and noise. Security. How are we more secure than Wi-Fi and legacy Powerline, or even legacy coax? So one of the things that G.hn has from a security standpoint is per-link encryption. So for example, legacy HomePlug or legacy Mocha or even Wi-Fi in general, if you took one access point and you somehow hacked into that system, your other access points in the network now are compromised because it's all on the same security front. It's all one big network that's attached to each other. G.hn has a thing called per-link encryption. So let's say you take, for example, power line adapters. You take out one power line adapter, let's say someone accesses that power line adapter. It doesn't even touch the other guys because it's completely segmented in its own security stack. So that's one of the key advantages from a security standpoint with this technology. And the one good thing is that we also hold to the same AES encryption as everyone else. So you don't get any lesser than that from an encryption standpoint. Why is G.hn the backbone to Wi-Fi better than Wi-Fi to Wi-Fi? So one of the things is, of course, from an SSID standpoint, from an aggregated SSID standpoint, you actually have that, what I was talking about before, security issues with different hotspots. So from an interference standpoint, this is specifically on G.hn over power line, because now this technology can work on, G.hn over coax, G.hn over POF. You don't have this interference with more shielded technology like coax, POF, or maybe sometimes phone line. From a power line standpoint, from a Wi-Fi standpoint, you have spectral issues, right? If you have two Wi-Fi access points that are just, overpowering each other, that's when you have that reflections back and your dB range goes to hell and your performance goes down. sorry, getting out of the weeds. What did she talk about with eating? So this is bad. So it's kind of like two people spraying each other with garden hoses, and the mist is like, overwhelming each other, and it's not good. From a legacy power line standpoint, HomePlug Technologies, the reason why HomePlug in retail has a high return rate. I was actually having a conversation with the head guy from Best Buy, and I asked him, so how is your HomePlug, because we just launched in retail within the year, and they were shocked that our return rate was so low in power line. Like, how is this possible? Our HomePlug return rates are like 15 to 25%. Like, well, in this technology, we have a thing called neighbor protection. The legacy power line technology doesn't have a thing where if you were in an apartment complex, you get power line adapters from, let's say, Best Buy, and you, based on HomePlug, you plug it in your one house. Your neighbor all of a sudden gets the same exact adapters, and then all of a sudden your throughput just gets cut in half. And you're like scratching your head, like, what just happened here? And that alone, if you think about an apartment complex, you say 20 people get this, and now that you're just crawling, right? Because you're seeing each other, you're spectrally bleeding into each other with the other legacy technology. With this technology, G.hn, we have a thing called neighbor protection. We actually protect you from your other power line adapters based on G.hn and even based on HomePlug. We're actually better at preventing spectral bleeds with legacy. It's actually better to get a G.hn power line with a HomePlug than a HomePlug one because they will actually kill each other from a spectral standpoint. Where we actually like that we shield it. It's actually a patent actually Marvell did that and gave to the G.hn community. So other G.hn providers like Sigma Designs, Xinterra, Metanoia can actually utilize that as well from a protective standpoint. Highest performance. Right now, HomePlug AV, or that technology band, has already at its maximum specification. From just going into the weeds, HomePlug in general can only go up to 86 megahertz because you don't want the ham radio guys to get pissed off that you're in their spectrum above that. So that's all it can go up to. So HomePlug AV has already launched with its highest. They've already done 0 to 86. That's the highest they can go. Because the MAC efficiency of G.hn is much more efficient, we actually have not even launched up to 86 megahertz. Everything has been launched only up to 50 megahertz, and we still outperformed them in test cases. So from a roadmap standpoint, this technology has further out to go, and we're actually doubling the performance every year. So it actually has a map towards the panacea of 10 gig, making sure that from a Ultra-Broadband standpoint, you can actually now support all the broadband that's coming down the pipe. So from here's a little bit going into the weeds of why Wi-Fi versus wired Wi-Fi is better. So when you're doing Wi-Fi to Wi-Fi, one of the issues with Wi-Fi to Wi-Fi is that it acts as a client and an access point. So when you go from one Wi-Fi to another Wi-Fi, it has to talk and receive at the same time. So you can't just talk and listen at the same time. You have to wait for it to listen, then you talk. So what that does from a talk and listen standpoint is that, let's say you get 100 meg. Instead of just getting 100 meg, you have 50 meg talking, 50 meg receiving. So you only get kind of half the throughput. From when you do a wired to wireless backbone, you're literally you're getting all that full 100 meg and spraying it back out. You're not compromising the talking and receiving. You're literally just, talking or just literally receiving. You're not compromising the actual throughput of client to Wi-Fi, wired to wireless. And then this is my only weed slide. If you want to understand why, from a packet level, this occurs, and what the latency is and what the capacity level is. So I'm not even go into this. This is just, you guys can get this and download it and do all you want with it. So from a delay networks, why is that so important? And one of the questions I get from a lot of the video SoC guys is, hey, we have buffering. Who cares about latency? You go, yeah, if you care, if you're in an IP world, like for example UVerse, when channel changing was a huge thing, you're going to care about latency. You're going to sit there and you're going to wait 20 seconds to try to go from one channel. Your user person is going to get pissed off, and then there you went. They're off your screen now. So everybody wants to make sure that their eyeballs are always on their user interface or user screen. So it matters when it comes to of course the two key things: gamers, channel changing. You do have a little bit of relaxation from the video world because of video compression and video buffering, but it still does matter. You know, you still can't have, you know, from a mesh network, a pure Wi-Fi thing because of latency. Yeah, and then I don't want to go into time division. Let's look at the time check, so I'm not going to go over on Rick's presentation. And so from a G.hn benefits, advantages, of course, once again, is security, no interference, and highest performance. I'm just going to go into a little bit on the coax side. So G.hn over coax, which of course is higher speeds because it's shielded, goes up to the 1 gigabits per second. I mean, the standard itself is ultimately hitting the 10 gig. Everyone's trying to do the 10 gig WAN and 10 gig LAN. That is the goal of the organization, to make sure that we can propagate and proliferate that type of speeds inside a home. Anyone have any questions? No? Am I? Anyone want to talk about Netflix versus HBO? I'm a Silicon Valley fan. Everyone watches that show. I live and breathe that show, and it's all true. I live and breathe that day. No questions? All right. Well, thank you guys for